Alright, this is the second video covering properties of parallelograms. The previous video covered an introduction, also discussed vocabulary and theorems needed to know to be able to solve problems involving parallelograms. This tutorial is going to cover assignment 5.2b. We'll go over how to solve some of these problems in case you're having any difficulty or were absent a day we covered this in class. So there's 4 different types of problems. One is the first type is gonna cover parallelograms. The second type will cover rectangles. The third, a rhombus, and then the fourth, a square. So the way these problems are going to get tested, there will be some problems where you'll be given characteristics of one of these shapes, and you'll have to identify what kind it is. And the most difficult part is differentiating a rhombus from a parallelogram. The best way to, what's best to know is that a rhombus has all 4 sides are congruent, whereas a parallelogram does not necessarily. Parallelogram that has all 4 sides congruent will be a rhombus. So just keep that in mind. So for the first 2 problems, they cover parallelograms, and you'll either have problems, you could have some with diagonals drawn in or some that do not. For number 1, it's talking about the diagonals, and so you're asked to find the entire length of one of the diagonals. So whenever you have these problems, you want to first ask yourself, what is this problem asking? So this problem is asking us to find NQ, which is this entire diagonal, and it gives us NS and SQ, which are the 2 halves of the diagonal. So you want to have your characteristic sheet next to you to make sure that you can refer to it in case you forget some of the characteristics. And the characteristics about the diagonals of a parallelogram is that they bisect each other. So what that means is that half of this is, so this NS plus SQ is going to equal the whole entire length NQ. So what you'll need to do is solve for x, and you'll use both of these right here to set up the equation to solve for x. So it would be, you have NS, so 2x plus 7, equals 5x minus 23, okay, because those are going to equal each other. They're going to be congruent, okay. And so then what you would do is solve for x, and then once you get x, you are then going to take x and you would plug it back in into either one of those, and you'll get half of the diagonal. So again, 2x plus 7 equals 5x minus 23. That will give you x, and then you'll take x and you'll plug in. Shut up! Plug it back into either one of those, and then because it's asking for the whole entire length, you'll multiply it by 2. Okay, so that's how you'll find that whole entire length. Okay, so for number 2, it's asking us to find this angle right here. And so it's important for us to understand that opposite angles are going to be congruent, consecutive angles are going to be supplementary. So in order to solve for x, you're going to have to set angle Q plus angle P are going to equal 180 because they're supplementary. So it'll be 8x minus 12 plus 3x plus 5 equals 180. And then that's going to give you x. And then you're going to take x and you'll plug it back in to angle right here to solve for angle P, and whatever you get for angle P is going to equal angle R. Okay, so again, 8x minus 12 plus 3x plus 5 is going to equal 180. That's the equation to solve for x. Once you get x, you plug it back in here. That will give you the measure for angle P, which will give us the answer which is the measure of angle R, because they are congruent. Okay, that's the parallelogram problems. Okay, and now for the rectangles. So for number 3, you're given the 2 lengths of the diagonal. So you're given RT and you're given US, the 2 diagonals, and you're asked to find VT. So you're asked to find half of the diagonal. So we know that this, if we can just find RT, So if we can get x, plug it back in here, we can divide that by 2, and that's going to give us VT. So we know that diagonals of a rectangle are congruent, okay, according to our characteristic sheet. So we would set our 5x minus 14 equals 2x plus 10. So set those equal to each other and solve for x, and then we'll take x, whatever we get for that, and we'll plug it back into here, into this expression for RT, and that's going to give us RT, this whole entire diagonal. Okay, and so then just to get VT, which is half this length, once you plug this in here, you're going to divide it by 2, and that's going to give you VT. Okay. All right, so for number 4, okay, I want to show you, I marked these, marked the sides, the congruent sides over here, and I marked the congruent angles over here for rectangles. So for rectangles, these 4 are congruent, okay, the 2 opposite sides are congruent to each other, and those 2 right there are congruent to each other. So we might use the triangle angle sum theorem, which means all 3 angles add up to 180, or we might use the isosceles triangle theorem, which means that if 2 sides are congruent, the 2 angles opposite the sides are congruent. And I've marked the sides over here, or the angles over here. And so these 2 angles will be on each triangle. As you can see, there's 4 triangles in the middle, so the 2 angles on each triangle are going to be congruent to each other. Those 2 will be congruent to each other, those 2 and those 2, but the angles on opposite triangles will be different. Okay, so for this problem, number 4, you're given expressions for this angle and this angle. You want to remember that alternate interior angles are going to come into play. So this angle right here, which is RXY, angle is going to be congruent to this angle right here because they're alternate interior angles. As you can see, I have these marked right here. So that's 1 mark and 1 mark, 2 marks and 2 marks. So this is going to be 5x minus 8 right there. And so we can solve for x. The problem is asking us to find xzw. So it's asking us to find xzw. So it's asking us to find this angle right here. So once we can figure out what x is, we can plug it into this expression, and that will give us this answer because this angle is congruent to this angle. So we know that the angle of a rectangle is 90 degrees. So to set up the equation to solve for x, we would just do this angle plus this angle. So it's going to be x plus 20 plus 5x minus 8 equals 90. Okay, because angle xzy right here plus angle wzx equals 90. Okay, x plus 20 plus 5x minus 8 equals 90. So combine like terms. Once you get x, we're going to plug it back into this expression right here, and that's going to give us this angle, and that's going to ultimately be our answer because this angle is congruent to that angle. So again, to set the equation up, it's this expression plus this expression equals 90. Okay, that will give you x, and you take x and you plug it back into this expression because this angle is congruent to this angle, and this angle is the angle that we're looking for, xzw. Okay. All right, last 4 problems. The next 2 are going to cover a rhombus. So for a rhombus, these marked over here. So you want to remember for a rhombus, so I've got the sides marked here, and I've got the angles marked here. So the rhombus, all 4 sides are going to be congruent. This segment's congruent to this segment, this segment's congruent to this segment. And then as far as the angles go, the 4 angles here are congruent to each other, and the 4 angles there are congruent to each other. And then the main thing to remember about a rhombus is the 4 angles in the middle are all 90 degrees. So this problem here, number 5, is it's telling us that x, y, z, so this outside angle is 136 degrees. It's giving us this angle right here, which is RXY. It's asking us to solve for x. Okay. So we know that this angle plus this angle, these are going to be consecutive angles, so they're supplementary. So we can get this whole angle right here by subtracting 136 from 180. Okay, and that's going to give us WZY right there. Okay, so 180 minus 136 will give us this angle. Now we know that this angle is congruent to this angle, so we can now solve for x by adding 10x minus 8 plus 10x minus 8 equals what we got for this angle. and then we would just solve for x. So again, we know that these two angles are congruent because it's a rhombus, and the diagonals bisect the angles that they intersect. So we can set the equation up to solve for x. 10x minus 8 plus 10x minus 8 equals, and what we get on the right side of the equation is going to be 180 minus 136, because this angle XYZ is supplementary to this angle. So 180 minus 136 is going to give us this angle, which will be on the right side of the equation. Okay. All right, for number 6, we are asked to find HG, which is going to be a leg of a right triangle. And for a rhombus, again, you want to remember that we have 4 right angles right in here, so we can use the Pythagorean theorem to find certain sides, which is what we're going to have to do in this problem. Okay. So we are given DE, and we are also given EF. Right? So we know that those are congruent to each other, so what we can do is we can set them equal to each other to solve for x. That's going to give us x. Okay? And then we can plug x back into either one of these equations or expressions, and that's going to give us this side right here. Okay? Because this side's going to be congruent to those sides. So if we've got DF is 52, this whole length. So we can get this length right here because this bisects this, so this is going to be congruent to this section. This is going to be half, HF is half of DF, so we would divide 52 by 2. That's going to give us this leg, and then again we get GF by solving for x and plugging x back into this expression. Okay, and then that gives us this side, and then we can now a squared plus b squared equals c squared. We have a and we have c, and then we would just solve for b. Okay, so again, first thing we do is solve for x, because we have DE equals EF, rhombus congruent. 16x minus 3 equals 9x plus 11. And that gives us x. You take x and plug it back into here. Okay, and then that's going to give us this whole length, the side right there, which is this side right here. So we have this side, and then we can get this side by dividing this by 2. So we have this side and that side, and now we can solve for this side by using the Pythagorean theorem. Okay, the last two problems. We've got number 7 and 8. These both involve squares. So all of the characteristics apply here. So for 7, we're given Ln, which is this diagonal right here. And it's asking us to find this diagonal. So we know if Ln's 46, we know the diagonals are going to be congruent. So we know that OM is going to be the same as Ln. So that's going to be 46 will be right here, and then Pn is just half of 46, so we just take 46, divide that by 2. Okay, so now it's asking us to find this side, and then it's also asking us to find this side, which are going to be the same thing, and then we would just use the Pythagorean theorem. We've already got a squared plus b squared equals c squared, so it'd be 23 squared plus 23 squared equals, this could be x squared, and just do the Pythagorean theorem to get ON. And which is also going to be the same as Mn. All right, and then the last one, we're just solving for x. So we're given this angle right here. So we know that this whole entire angle is 90 degrees. So to solve for x, we would just do 6x minus 21 plus 6x minus 21 equals 90. Okay, combine like terms, so it would be 12x minus 42 equals 90. That would be the equation to solve for x.